Let us solve exercise 3 of the physics exam for the first session 2022. Exercise 3. Study of an electric circuit. The electric circuit of document 2 is formed of a generator G that maintains across its terminals a constant voltage UPN is equal to 9 volts. 3 lamps L1, L2 and L3, a switch K connecting wires. As we can see that 2 lamps L2 and L3 are connected in parallel to each other and all together are connected in series with L1. So number 1, the switch K is closed. The voltage across L1 is UAB, which is equal to 3 volt. 1.1, knowing that UPA is equal to 0 volt and UCN is equal to 0 volt, determine the voltage across BC, UBC. UPA is across the switch, which is a closed switch, and of course it's 0 volt. UCN across a wire, and the voltage across a wire is 0, and UBC is the voltage across L2 and L3. We want to calculate UBC. So let us apply the law of addition of voltage in series circuit. First, UPN is equal to UPA plus UAB plus UBC plus UCN. Then we can plug the numbers that we know. UPN is equal, UPA is across the switch, which is 0 given, plus UAB is equal to 3 volt, also given. UBC, this is what we need, plus UCN is 0, also given. Now we can take the 3 volt before the equal, it will become minus 3 volt, and we can calculate UBC. So UBC is equal UPN minus 3 volt, and UPN is given 9 volts. So 9 volt minus 3 volt, which is 6 volts. So UBC is 6 volts. Number 1.2, deduce by indicating the law used the voltage across the terminals of L2 and that across the terminals of L3. We know that L2 and L3 are connected in parallel. So law of uniqueness of voltage in parallel circuit. So UBC is equal to U2 is equal to U3, which is equal to 6 volts. Number 1.3, the generator sends a current I1 500 milliampere. The current through L2 is I2 is equal to 300 milliampere. Determine the current I3 through L3. So as we said that L2 and L3 are connected in parallel, so we can use the law of addition of current in parallel circuit. So we can write I1, which is equal to I2 plus I3, but we need to calculate I3, so we can rearrange it. I3 equal I1 minus I2, so 500 milliampere minus 300 milliampere, which is equal to 200 milliampere. Last number, part 2, the switch K is open. Give the new values of UPA and UBC. UPA is across the switch, and whenever the switch is open, the voltage will be equal to the battery, so it will be 9 volts, same as the voltage of the battery. While UBC, it's across the lamps L2 and L3, and the lamps are off, so 0 volt is the UBC since the lamps are off.